going to talk about central angles and arc measures. And let's just recall from Monday when we learned a whole bunch of vocabulary about circles that a central angle is formed by the intersection of two radii, which they intersect at the center, obviously. So the central angle is the sides are radii and its vertex is the center of the circle. So if we're looking at the example here, we have central angle ABC. Now this central angle intercepts, that's what it's called, intercepts a part of the circle. Think of it as like pizza crust here. This pizza crust we know is called an arc. And in this case, this angle ABC intercepts arc AC. Now, arc AC can be determined or measured two different ways. One, it has a measurement like an angle in degrees or radians, which we'll talk about at some point. And it can also be measured by its length. We could cut out our crust, our pizza crust, and stretch it out against a ruler and measure it. So we're gonna talk about degrees first, and then we're gonna talk about, in a couple minutes, we'll talk about the length. So again, the central angle is formed by two radii and its vertex at the center. And the number of degrees of the central angle is the same as the intercepted arc. The other thing to realize is that in a circle, the number of degrees all the way around the circle or all the way around the center, meaning the sum of all the central angles is 360 degrees, which means the sum of all the arc measures is also 360 degrees. So if we have a central angle of 84, this is called the minor arc, is also 84, then this central angle on the other side of 84 is 360 minus 84, or 276, which makes the major arc ADC also 276 degrees. Okay, so I did example number 1 earlier, and I just wanted to point out two things. We have two diameters, and at their intersection form two vertical angles. So these two central angles are congruent because they're vertical, which makes these two angles also vertical, which means that they are 180 degrees minus 21 or 159. So again, if the central angle is 159, then the measure of the arc is 159. So you can see where I got all these numbers from. I'll do number 3 with you as well. Number 3, we're given that this arc length, or this central angle, is 90 degrees, right angle. So that means that arc measure CD is also 90 degrees. FD we need to find, so FD, well, let's see. If this is 90 degrees, then GHE is also 90 degrees, which means this angle right here has to be 90 minus 34, which is 56. So this one is 56. Oh, look at, if this is 90, that has to be 90. Look at that. This is fun. So this is 90. That's 90. Is this 90 as well? This is 90 as well. 90 degrees. So what do we need to find now? Look at this. We need to find FD. So FD, that's 90 plus 34, is 124 degrees. Then we need to find DCF. So DCF, 90, 90, 56. What's 180 plus 56? 236 degrees. And then we need to find GDF. So let's find, look at GDF. That's everything except for 56. So GDF is 360 minus 56, which is 304 degrees. Okay, got it? All right, let's take a look at number 7. I worked this one out. This is involving algebra. So we're given that we have, in orange, I highlighted the arcs, and we know that they're congruent because they're vertical, their central angles are vertical. So I went ahead and I solved for x. I got x equals 17. In order to solve for AD, that was one of the questions, how much is AD? Well, I plugged 17 in for x, so 8 times 17 plus 12 is 148. And then I needed to find CD, so that's 180 minus 48, or 32. And then I needed to find BDC, that's the major arc in green here. That's 180 plus 32, or 212. So that's how you find the measures of central angles and the arc measure. You are going to do problems 2, 4, 6, and 8. We're also going to talk about arc length. Now, arc length is denoted by this letter L. This is a cursive, a lowercase cursive L, and that's what we're going to use to call arc length. Here's the formula for arc length: x over 360, where x is the measure of the central angle, or the degrees of the arc, either way you want to look at it, times the circumference. So it's the degree over 360 times 2 pi r, or if you're given the diameter, you could use pi d, either one. Okay, so number 11. We're given NR is 8, so NR, let me highlight that, NR is the radius. So we're given the radius, and we have to find the length of NMP. So I highlighted that already in green, NMP. So it's 162 plus 18 plus 18 again. So the measure of angle NMP is 196 degrees. So I'm going to plug into the formula. The arc length is 198 over 360 times 2 pi r. In your calculator, this is what you do. 198 times 2 times 8. Write that number down and put pi, and that's over 360. And now you can say 3168 times the pi key divided by 360 is equal to 27.65 feet. Number 13, I'm going to do this a similar way. First of all, we're asked, we need to know the radius of the diameter. In this case, we're given the diameter. We're given JH, so that's this diameter. And in green, I highlighted the arc length that we need to find. So that's 360 degrees minus whatever kg is. So I went through, similar to what we talked about a couple minutes ago, and figured out what all of these central angles measured. 95. In order to figure out the arc measure, which turns out to be 334 degrees. So here we go. The measure of the length of the arc is 334 over 360 times pi d. Multiply these two numbers over 360 pi. Then I put this in my calculator and I get 61.21 inches. Number 15, I need to find the measure of TS, or the measure of TS, so that I can find the length of TS. So I'm given that WS is 4.5, so WS is the radius, and I need to find the length of TS. So I need to find, well, how many degrees is this arc? Well, if PWQ is 128, then that means that TS has to be 128 minus 31. which is, oh geez, 97, right there, 97. So here we go. The arc length is equal to, I'm using the formula, 97 over 360 times the circumference. The circumference, I'm given the radius, so 2 pi times r, 4.5. Use my calculator here. So I have 97 times 9 is equal to 873 pi over 360. So I'm gonna, just give me a sec. That should be about 7.62 millimeters. Okie doke. So if you have any questions, just shoot me an email or post to our question page. All right?